This is one of our factors. This is one of our factors. This is one of our factors. And this is our remaining factor. Because, if you recall, to get these factors here, we actually factored this whole expression. So if I'm going to clean this up and write those factors together, I typically will start with my constant out to the left. So I'm going to have 2 times x plus 1/2 times x minus 3/5 times 5x squared minus 5x minus 20. Now, there's a couple of things that we can do at this point to make it even friendlier. And we saw it in the example from the textbook. They didn't explain it step by step. So if I take this 2 and distribute to that first set of parentheses, what do I get? 2x plus 1. So I get that as a factor. And now, what do you notice over here? They're all multiples of 5, which means we can factor out a 5. So if we factor out a 5, we're going to be able to then distribute that 5 to this set of parentheses here. So if we factor out a 5 and we're left with x squared minus x minus 4, we can take this 5 and distribute to this set of parentheses. So what will that give us? 5x minus 3. And then we'll have this trinomial as our last factor. So we'll have x squared minus x minus 4. And now we can solve that quadratic using either the quadratic formula or completing the square. Now I'm going to use completing the square. I'm sorry, were there questions?
No, I was just trying to think like a list factor.
Yeah, it's not factorable.
Yeah, I thought it was.
So if it was factorable, then the roots that we would get from those factors would be rational.
Yeah.
And the point of this is we're actually using the rational root theorem to get not only the rational roots, but then to take that remaining quadratic and to turn it into the irrational roots.